Hey everybody, this is a video for my 40S Pre-Cal students. I'm going to go through the 6 questions in the homework assignment, or one of the homework assignments you're getting for Chapter 5.2. On the one hand, because A, it needs an answer key to be made anyway. I can't seem to find the one from last year. And B, that way if you're stuck on anything, you can just fast forward to the point in the video that you need, or if you're feeling particularly sleep deprived, you could try watching the entire video and that ought to do it. So let's get started. So I'm going to start with number 1. Construct accurate sketch of y equals -2 sine x minus pi by 4 plus 1. So let's start by figuring out what a, b, c, and d are, shall we? Okay, so our a value is definitely -2. Our b value is just 1. There is no extra b value. Our c value is minus pi by 4. And our d value is 1. Okay, so if our b value is 1, remember that we have a little formula that says period equals 2 pi over b. So since the period is 1, or since b is 1, the period is 2 pi. And I need a c of -pi by 4, so that's kind of made me decide that I'm going to count in quarters of pi. So you'll notice I have a nice grid here kind of ready to go that goes from 6 to -6 in the y direction. But notice I kind of didn't decide on an x scale, because you don't decide on the x scale till you kind of know what you're counting by and what you need to count to. So to get a full period in, we have to count to, starting at -pi by 4, we have to go 2 pi from that. So I am going to make every 2 little squares here pi by 4. So that's going to be -pi by 4. That's 0. That's positive. So 1 quarter, 2 quarters, 3 quarters. There's pi. So 5 quarters, 6 quarters, 7 quarters, 8 quarters. There's 2 pi. And there's 1 quarter past 2 pi, which I'm going to... Oh, no, I guess I'm going to end 1 quarter before 2 pi. So that's good enough. And I guess I could just keep counting here in quarters of pi. Notice that it is easier to do these on grid paper, and that's why I'm using grid paper. And I've got Desmos down here at the corner to help me along and to just check my answers when I'm done. I'm going to see if I can make this just a little bit less blurry. I don't know if that helped or not. My eyes ain't so good. Okay, so I'm ready to start graphing. I always graph the d first, so d is 1. So that means I have a central axis at 1. So there's my central axis. And I have a, what's the next thing I'm going to do? I'm going to do a. A is 2. Notice I'm not looking at the negative right now, I'm just looking at 2, which tells me that the amplitude is it has to go up 2. I guess, yeah, up 2 and then down 2. So 1, 2. So there's my max and my min. Okay, so I've got a max, I got a min, I got a d. I'm ready to put down my starting point. So my starting point is pi by 4 to the left. Oh, wait a minute, sorry, hang on. I just realized I misread the question. C is just positive pi by 4, looking down here at the question, just pointing at it down there. Looking down there at the question, it actually says minus pi by 4, so actually C is positive pi by 4, so I did need to go to there. So I'm going to start here, but on the d value. And then the last thing I have to kind of keep in mind here before I keep drawing is that a is a negative, which means that normally a sine curve starts and goes up and then down, but this one's the reflection of that, so it's going to go down then up. So it has a full period. It goes a full crest and trough, or in this case trough then crest, starting at pi by 4 and ending at pi by 4 past 2 pi. So there's one whole period of my graph. And that means that the middle point will be halfway between, say, 1/4 of pi and 2 1/4 of pi. Or feel free to just name these 1, 2, 3, 4, 5, 6, 7, 8, 9. what's halfway between 1 and 9? Well, 1 plus 9 divided by 2 is 5. So 1, 2, 3, 4, 5. There is the midpoint where it's going to hit its node. So it's going to go down, then up from there. And have I counted this wrong? 1, 2, 3, 4. 1, 2, 3, 4. No, it's just the x-axis is kind of playing tricks with my brain here. Okay, and then for the same logic, halfway between the starting point and its node, it should hit its minimum. So that'll be 1, 2, 1, 2, so right there. And then same thing, it'll be 2 and 2. And the reason I'm just counting these because I know this thing is symmetrical. So 1, 2, and right there. And there's my graph. It is going to go down. Oh, I drew that really badly. Let me fix that. It's going to go down, up, and down. Something like that. Put an arrow on this side, an arrow on that side, and I think we're pretty good. And it's not a bad idea to kind of give your 5-number summary. And your 5-number summary here is that it's going to start at the point, now this is pi by 4, comma 1. It's going to end at pi by 4 past 2 pi. So that's going to be 2 1/4 pi, if you like. Or if you want to change that to an improper fraction, that'd be 9/4 pi. It has its nodal point at 1/4 past pi, so that's 4/4, 5/4. And it has a minimum here at 3 pi by 4, and that'd be -1. And it has, let me move that up a bit, and then it has a maximum of, let's see, what's the maximum here? The maximum here is going to be 1/4 before I hit 2 pi, so 2 pi is 8/4, so that's 7/4 pi. And 7/4 pi, and 1, 2, 3. All right, so there we go. So we've got ourselves our graph. I would like to check to see if I've got this right. So I'm going to take my Desmos window here, and I'm just going to kind of bring it over a bit and see if I can kind of compare it. So let's see. Let me go to my Desmos window here, Desmos, and turn on the graph. And there we go. That's looking pretty good. Let's see if my points are the same. So I said that my starting point here would be pi by 4, 1. And yeah, that looks like pi by 4, 1 is pretty good. 1, let's see, where are you, 1? You know, if I'm actually not sure if I've hit the point properly, what I can do is I can actually type in points. So let me just type in a point and make sure that I've hit the point exactly. So pi by 4, comma, it's comma 1. There, oh, pi by 4, sorry, comma 1. There we go. And yep, there's my starting point. And I go down to this minimum here, which is 3 pi by 4, -1. And then I go up to my maximum, which is 7 pi by 4, comma 3. I've got the right graph. So this is the graph that it is supposed to be, I believe. So yay me. Okay, so let me kind of put that back kind of into the background here. And just kind of hide that a little bit. There we go. And all right, so that was number 1. I guess I should number these so that people can kind of go through the video and kind of see where they're at. So that was number 1. So let's move on to number 2. And for number 2, we're going to go to here, and we'll just scroll up a bit. Scroll up. And there we go. Okay, so for number 2, notice I'm basically using the same grid, but notice I'm still doing that same kind of thing where I'm not really, I'm not putting in an X grid until I actually know what I want to count by. Okay, so for number 2, let's see what we got. we have an A value of just 1. So the amplitude on this one's just going to be 1. We have a B value. This is number 2, by the way. We have a B value of 2. We have a C value of negative pi by 2. And we have a D value of negative 1. So let's see what we can do with that. Okay, the A being 1 means that my amplitude is fairly small, so this is only going to go up and down one place, but it's going up and down from a central axis at the -1 line. So there's my central axis. Should probably do this with a ruler, but this video is going to take enough time. So D is -1, and okay, so my A is 1, so I'm going to go up to my x-axis and down to -2. So there's my minimum. Okay, we're ready to keep on graphing. Now, for this one, my B value is 2, so let's figure out what the period is. So the period is going to be 2 pi divided by 2, which is pi. So this thing's going to have a complete crest and trough in pi units. So I'm going to maybe I'll probably just count the same thing. I'll count in quarters of pi. So 1/4 pi, 2/4 pi, 3/4 pi, pi. 1/4 pi, 2/4 pi, 3/4 pi, 2 pi. And there we go. And this was completely arbitrary that I'm counting in quarters. You can count in half pies if you want. It just means your graph will be a little more squooshed together. Doesn't really matter. As long as you label what you're doing. Negative pi. Oops. That's negative pi by 2. Or that's negative pi by 4. So 1/4, 2/4, 3/4. Maybe I shouldn't count and talk at the same time. There we go. Negative pi. Negative 1/4, 2/4, 3/4, negative 2 pi. There we go. So as long as you label what you're doing, it doesn't really matter what you count in, as long as your graph is reasonably accurate. Okay, so now a cosine starts at its maximum, and its C value is negative pi by 2. So it's going to start at negative pi by 2, right? If these are quarters, that's 1/4, 2/4, and 2/4 is a half. So that's another good reason to stay in quarters, is because halves hit all the quarters. So this is negative pi by 2 right here. I could even label it if you like. And it's going to be where my graph starts. And my graph starts on its maximum, right? Because it's a cosine graph. And then it's got a period of pi. So pi is 4 of these ticks. 1/4, 2/4, 3/4, 1 full pi. So there's where the next peak is going to be. So it's got a maximum here, then a maximum there, which means it'll have its minimum right in the middle, and its node will be right there, and its next node will be right there. So feel free to now graph. And yeah, it's easier to graph when you make sound effects. Most people don't realize that. And this time, you know what we'll do different this time is we'll just keep drawing. This one's an easy one to draw the way I've scaled it. It's actually fairly easy, so I'll just kind of keep on making crests and troughs. It doesn't say in the homework how many periods it wants you to draw. It just says make an accurate sketch, so I'm doing my best to make a fairly accurate sketch here. But there we go. And so let's see. Actually, I don't really like the way I've kind of missed that point there. So that would be back to here, back to there. And so up. Upsy daisy. Upsy daisy. Something like that. Kind of got a little bit oogly towards the end, but you get the idea. All right, so there's number 2. There's what I think number 2 is. Let's go to Desmos and see how close we are. So Desmos, come on over, and let's see where we're at here. So Desmos, we're going to shut off this one, shut off that point. I don't really need that anymore. I could pick some points for the next one here, but let's see. Cosine, and let's see, how close are we to our graphs here? Let's see, that looks pretty darn good, doesn't it? I'm just looking and comparing for myself. Again, the crests and troughs got a little bit ugly there, but overall, I'm pretty happy with this. I guess, you know what, this is offending me. I gotta fix that. There we go. Looks more like a wave now. Okay, so there we go. There is our cosine curve. And again, I could go through the 5-point summary and see that on this graph here on Desmos, I actually do hit all the points I'm supposed to. Right there was my starting point was right here at pi by 2, 0. My ending point was pi by 2. Sorry, at negative pi by 2, 0. My end point was pi by 2, 0. There was my my minimum, and there was my node right there and right there. And I could very easily verify that I have everything correct. So we got this one. Let's kind of get Desmos out of the way and draw the next one. Okay, so let me just label these so I don't get confused here. So this is number 1. This is number 2. This will be number 3. Okay, and let me just go to my page here and roll up a bit. Number 3. Okay, so number 3 is y equals negative 0.5. So a is equal to negative 0.5. I like fractions more than decimals, so I'll just say negative by half. Sine of the b value is also 1/2. And the c value is positive pi, and the d value is 2. Okay, so what is this one going to look like? Well, again, let's start by figuring out our period, which is 2 pi divided by 1/2. Careful there. I still have a few people in class who are not maybe 100% comfortable multiplying and dividing by fractions. Remember, when you divide by a fraction, you multiply by its reciprocal. So your period is actually 4 pi here, or 4 pi over 1, which is 4 pi. Okay, so if that makes sense to you, that's the way it's going to look. What should we make our graph scale? And this time I think I will maybe pick a different scale, because the last time I picked a scale that kind of 2 pi was over here. Well, I have a period of 4 pi on this one, so this is a much wider graph. So I might just count in pi's this time. So this will be maybe I'll count in pi by 2s. So 1/2 a pi, 1 pi. 1/2 a pi, 2 pi's. 1/2 a pi, 3 pi's. And 1/2 a pi, 4 pi's. And 1/2 a pi, 5 pi's. There we go. And let's see. Oh, I guess we better count backwards too. So 1/2 a pi, negative 1 pi, 1/2 a pi, negative 2 pi's, 1/2 a pi, negative 3 pi's, and 1/2 a pi, negative 4 pi's. That should do it. Okay, so from there, what do I need? I need my d value to be 2. So up at 2, we have our central axis. And oh, kind of lost the line here. Sorry. Again, my eyes aren't so good. And okay, so there's my central axis. My a value is, okay, so my a value is actually negative 1/2. So I only go up 1/2 and down 1/2 from this. So if that's a 1, then 1/2. This is going to be a very interesting one to draw. This one, maybe I should, actually, maybe what I should do, I'm thinking I'm going to just change the scale here. So I make something easier to draw. I am going to make this, look at this, this is very clever of me. I'm going to make this a 3 and a negative 3. And now that's 1/2 1, 1/2 2. This will make it easier to draw. Clever, clever me. I am so smart. SMRT. Little Simpsons reference for you there. D. Okay, so that's the D. and now I go up a half and down a half, and since I've relabeled the scale, these ticks aren't ones anymore, they're halves. Yes, I can do that. It's my graph. I am the god of this graph. I can do whatever I want to it. So down a half. I should maybe qualify what I just said. I can do whatever I want to this graph as long as it's consistent. Every once in a while I'll see a student who goes, oh, I'm running out of room and I'm counting by pies, so then I'll just go, they're counting by half pies and they run out of room, so they'll go a half pie, 1, 1.5, 2, and then 3, 4, 5, 6. Can't do that. Your scale, whatever you choose your scale to be, it has to be consistent within whatever graph you're making. Anyway, so we have to go down a half and we have to go up a half. And there we go. There's our min and our max. And let's start drawing. Our C value is at pi. So okay, what are we a sine or a cosine? Which one are we doing again? This is number 3. It's a sine. So sine graphs start on their node, right? So we're going to start with a nodal point at pi and the D value. So there we go. So there's our starting point. The A is negative, so once again it starts by going down, then up. It's a reflection. And it has a period of 4 pi. So that means it makes one entire period by the time, oh, I made this a little, this is going to be in the way a bit. So its final resting spot for one period is going to be over there at 5 pi. Right, because the distance from pi to 5 pi is a period of 4. I'm off the screen a bit, aren't I? Period of, let me move over a bit. There we go. There we go. Just overlap this a bit. How about that? There we go. This is number 3. 4 pi. So this is number 3. All right, I am ready to start graphing now. I've got my starting point, my end point. It's a sine curve and it's going down first, then up. So the distance from 1 to 5 is a distance of 4, the middle of 4 things. 1 plus 5 is 6, 6 divided by 2 is 3, so the middle will be right here at 3 pi. So there's the other node. It'll have its minimum first at 2 pi, its maximum at 4 pi, and I am ready to go. So something like that. And again, if I wanted to draw more, it's a fairly easy one. Count to this, right, from pi to 2 pi is where I'd get to my next kind of peak. So I'd get my next peak there. And my next trough will be down here. Good enough. There we go. Something like that. So let's see. Desmos, take us away. Let's see if we can make this look the same. Again, I've already kind of pre-entered this. Here we are on this one now. And okay, so now right now that doesn't look the same as mine because remember, I changed the scale this time. This one is doing the same thing my first two graphs where it's counting in quarters of pi. And I've shown you this on a previous video, but if you haven't seen it, here's how you change. I mean, you can change the scale by zooming in and out, but if you want it to count along the axis in a specific amount, go to graph settings and change the x-axis to let's see, you can actually type the x-axis in pies. I can actually count from negative 5 pi to positive 5 pi. And then I can ask it to go in steps of what I have, which is pi by 2s. And ba-doom. And now it should look very much like what I have. And let's see. Pretty close. Although, again, I changed the y scale. So we can do that too, if you like. We can change the y scale to what I have. And let's see, what is my y scale? I'm going from, instead of from 6 to negative 6, on my y scale, I'm going from negative 3 to 3, and there we go. So now it looks very much like what mine looks like. Very nice. Okay, let's get Desmos out of the way again. And let's move on to the next one, number 4. And I can't seem to make that go where I want it to. Maybe if I shrunk it a little and shrink it a little more and pull it down a bit, pull it up a bit. I can't. That's the best I can do. What if I go like this? There. Oh, perfect. Okay. So, number 4. Okay. Oops. Moving things around more than I'd like to. All right, number 4. Number 4 is going to have a, let's see, it's a cosine graph, and its A value is 3. Its B value is 2. Don't let the fact that there's no bracket before that 2 kind of mess with you. That's the same as if you'd have written a bracket around the 2. The C value is a negative this time, negative pi by 4, and the D value is a negative 2. So I think I'm going to go back to what I was at before, where this is 6, negative 6, and I'm counting in 1 pi by 4, 2 pi by 4, 3 pi by 4, pi, 1 quarter, 2 quarters, 3 quarters, pi, and negative a quarter, 2 quarters, 3 quarters, negative pi, 1 quarter, 2 quarters, 3 quarters, negative 2 pi. Okay, so my period on this one is 2. So B is equal to 2, so my period is equal to 2 pi over 2, which means that my period on this one is pi. We've seen this before today. So that means I start at negative pi by 4, but I move, I guess I should put D down. D is at negative 2. And my A value is 3, so I have to count down 1, 2, 3, down to negative 5. And up 1, 2, 3. Okay, so I have a D of negative 2 and an A of 3, up 3, down 3. Okay, my A is positive this time. This is a cosine graph. So this means that I'm going to start at my maximum at pi by 4 to the left. And there's where I'm starting. Pi by 4 to the left at my maximum. It has a period of pi, which means I'll hit the next maximum in pi units, and I'm counting in quarters, so 1 quarter, 2 quarters, 3 quarters, 4 quarters. So at 3 pi by 4, I hit my next maximum. Right? That's a distance of 1 full pi, which 4 quarters of pi is 1. And okay, so there is 1, 2, 3, 4, which means halfway is 2. There's going to be where my minimum is. And again, my, oh, wait a minute, sorry. Minimum's way down here. Minimum's way down here. There we go. That's where my nodal point's going to be. So my nodal point will happen at 1 and, or at, sorry, negative 2. And there we go. I'm ready to graph this thing, I think. Maybe I'll make a couple more. So every time I move over a quarter, I get to one of my points I should draw, right? And move over a quarter and that one. Move over a quarter and that one. Move over a quarter and that one. Move over a quarter and there. Move over a quarter and there. And I'm ready to start drawing. Let's see. Oops. Oh, jeez, that's terrible. My sound effect didn't help me there. There we go. Something like that. And I could make that a little higher, I guess. And let's see, we could go this way for a while too. So I'm going to have a node there and a minimum there and a node again here and a maximum here and a node there and a minimum there. And I'm ready to draw. This one's actually kind of not very good. We'll take it though. There we go. Okay, let's get Desmos involved. Move that up a bit. Move Desmos over. Let's have a look. Oh, Mr. Desmos, how close is my graph to yours? Okay, so I want to go back to the scale I had before. So I'm going to go back to negative 2 pi's and 2 pi's. So I'll just go maybe negative 2.5 and 2.5 just so you can see it better. And I will, the y-axis, again, I'm going from negative 6 to 6. And I'm not graphing this one anymore. I'm graphing this one. And yep, that looks pretty darn close to, oops, maybe I could move that up a bit. Hang on. Desmos. There we go. There we go. That looks pretty darn close to what mine looks like. It has its maximums at the right point, right? So let's see, what was that maximum here? This is the maximum that I started with. Let me see if I have the exact right point according to what I drew. My maximum is at pi by 4, 1. My next maximum is at 3 pi by 4, 1. My minimum is at pi by 4, negative 5. And there's my nodal point at 0, negative 2. And that's kind of my 5-number summary right there. Kind of done for me. Thanks, Desmos. Aren't you swell? Okay, let's kind of go back to centering that. And maybe zoom out a little. There we go. And turn that one off. And get Desmos kind of, oops, moving the wrong thing. Desmos, move you out of the way again. And let's do number 5. Last one I'm drawing. Did they give me a tough one for the last one? Sometimes they do that in your homework. Number 5. All right, so number 5 is a sine. And let's see what we've got for that number 5. Okay, so for number 5, it says y equals sine. A is 1 this time. That's kind of nice. B is pi. Finally, they're actually giving us an easy one. You'll remember I said this in class. I'm assuming you remember everything I say in class because, you know, I certainly do. Remember I said in class that when the b value has a pi in it, your period actually becomes much easier to count in because your period actually becomes 2 pi divided by pi. The pi's cancel, and you can count on your grid in whole numbers. You can just count by regular numbers. So I can count by, let's say 1, 2. Actually, I might even count in halves because this is, so a half, 1, and a half, 2, and a half, 3, and a half, 4. Because, you know, this thing doesn't have a very long period. It's just 2, so the actual width of an entire thing will be from, say, here to here, and a width of an entire crest trough. All right, so there we go. And a half, negative 1, and a half, negative 2, and a half, negative 3, and a half, negative 4. Yay! Okay, so there we go. We've got A dealt with, we've got B dealt with. Our C value is, what is our C value? Negative 1/2. There's another good reason to count in halves. C is negative 1/2. They use 0.5. Positive 1/2. They use decimals. I like fractions better. And my D value is 3. So starting at a central axis of 3. There we go, central axis of 3. And we go up 1 from there. And we go down 1 from there. There's my maximum line. There's my minimum line. There we go. And let's see, my C value is 1/2, and this is a sine graph. A is finally positive on a sine graph for the first time, which means that we're going to start by going up, then down. And we start at the 1/2 mark, which is right here. So we start at a node, and we have a period of 2. So starting at a half, a period of 2 would take us to 2.5. And again, you can just count these ticks now as 1, 2, 3, 4, 5. The middle of that would be, let's see, so 1, 1, 2, 2. So right there is the middle. Very nice. And my crest, my maximum's there, my minimum's there. And I could draw several if I liked. It's a pretty easy one. Again, I can go up to here, down to here, down to there. And at this point, I'm just counting. So up, C. Oh, oh my word. That one got away from me. Sorry. There we go. And let's go into the negatives, shall we? So we go down to here, node max, node min, node max, node. I think that takes care of it. Down, up, and down, up, and down. There we go. Sine curve. Let's see if Desmos agrees with us. Oh, Desmos, what do you think of the fifth graph? So let's see, that would be this one here that I just did, and boom. And okay, I am going to again change. I'm actually counting in pies. I don't need to. I can just count in steps of 1, and I didn't go all the way to -8 and 8. I actually went to about -5 and 5. And let's see, how close does that look to mine now? Compare them. That looks pretty darn good. Let's close that. There we go. Pretty good. And again, my maxes and mins are at the same point. Beautifully done. Very nice. Okay, so that takes care of all the graphing questions. Next, I'm going to get rid of Desmos now. I can kind of just close that window capture. Well, actually, no, I'm going to hang on to Desmos. I'll keep it off to the side, but I might still graph the other ones. But okay, now for number, or actually it's not even number 6, it just says part B. For part B, it says, moving on to that one here, it wants a sine and a cosine for each one of these two graphs. So let me make that a little bigger. There we go. I only really need to see one of them. Okay, so in terms of sine and cosine, what does this graph kind of look like? And let's just move it over kind of out of the way, and I could just and there we go, part B. Okay, part B. How do I figure out what this is a graph of? All right, well, let's take a look at it and kind of think about it. Well, if it's going to be a sine graph, I'll do the sine first, then it actually has a C value of 0. Because notice it actually starts on with its nodal point on the y-axis, which is what a normal sine curve does. Its max and its min, it looks like it has a maximum of 3 and a minimum of what looks to be -1. So that means it's halfway 3 plus -1, and then cut that in half. It looks to me like it's going to have a D value of 1 and an amplitude of 2. But if I've decided that it starts on its y-axis here, if I've decided it starts there, let's see, hang on a sec, let me go to that page. If I've decided that it starts here at its on the y-axis, then I've decided that it goes down first and then up. So I've actually decided that I have to have a negative on the A. Okay? If I've decided C is 0 and I've decided that that's the starting point on the y-axis, it has to have a negative on A. I didn't have to choose that. I could have chose to make C a positive, looks like a +1, and then this would not have a negative on it. And I'll show you that when I'm kind of done with Desmos. Anyway, we've got C, we've got D, we've got A. All that's left is period, and as I'm counting this thing, it makes a complete wave. It goes down, then up, then back in a distance of, that looks like 1, 2, 3. It looks like we're counting in quarters of pi. So it makes a complete wave in pi by 2. So my period is pi by 2. Oops, not 2 pi. I said pi by 2. Right? And again, how do I know that? Because I know looking at the scale, it makes one complete wave in a half of pi, because those are counting in quarters of pi. So that's my period, and remember that b is equal to 2 pi over period. So b is equal to 2 pi divided by pi by 2, and we just talked about this. When you are dividing by a fraction, you multiply by the reciprocal, and so those cancel, and the answer for b is 4. So I have what I think now is my, shrink this down a bit, get out of my way a little, move over a bit there. I have now what I think is my equation. I think I have y equals -2 sine, and then open the bracket and put the b value of 4, open another bracket and put in x, c is 0. Actually, you know what, if c is 0, I don't need another bracket. 4 pi is good enough. And plus d is plus 1. So there we go. There's my equation. If I'm in sine, let's do that if I was in cosine. Okay, so in cosine, let me just do that on here. Piece of loose leaf. And I kind of want to see that part there, see if I can, oh well, I can't rescale that. So if I was making a cosine graph for this, okay, so now the cosine graph, definitely a cosine graph starts at its crest, at its maximum. So I'm going to pick the peak just to the left of the y-axis as my starting point. So that means c is a half of a half pi, or sorry, a half of a quarter pi. So that's actually going to be minus 1/8 pi. So minus pi by 8. Okay, so that's the c value I'm going to start with. Notice period doesn't change, so the b value doesn't change. Notice that the amplitude doesn't change, so the a value is still going to be 2. But in this case, since I'm starting at a maximum, which was what a cosine graph normally does, it's not a reflection. I don't need a negative on that too. The d value also doesn't change. The central axis is still the central axis. So the central axis, what did I say it was 1. So my equation for cosine is y equals 2 times the cosine of, open a bracket 4, open another bracket, pi, or x in this case, sorry, plus pi by 8. Remember that the formula is minus c, so if c is a negative, it's minus a negative, that's why it's plus, and then plus 1. And okay, let's see if we can make Desmos show us that those two things are the same. So first of all, I was playing around with this, but I actually didn't put them in properly. I have to actually fix that first. So let's see, go to Desmos here. And on Desmos, okay, so the first one I have -2. This should be a 4, not a pi. There we go. And I can make that go away. And this one I have, this should not be a pi, this should be a 4. And this should not be a 1/2, it should be a pi by 8, right? Just making sure that that's exactly what I have written there. Okay, so there's my two equations. I'll just kind of put them on the screen at the same time if I can. Let's see, can you see them? Oh, no, you can't because the other window is in the way. Let's see, let me just move that over for just a sec. And, okay, so there's one equation right there. And the other equation is sort of right under it. Again, let's just move Desmos a little bit. There it is. Okay. So there's my two equations. Let's just double check that I typed them properly. I think I did. Let's go back to Desmos. Desmos, we typed them as Minus 2 sine 4x plus 1, yeah, and 4, yeah, looks good. Now let's look at the graph again that they gave us. So the graph that they gave us, where are you, other window capture, there you are. The graph that they gave us, let's just make this a little bigger for a sec. The graph that they gave us starts, counts in quarters of pi again, and it only actually goes from, say, -1/4 pi to pi. So that's what I'm actually going to change Desmos to. So let's go to Desmos, video capture 2. There we go. Go back to Desmos, move that kind of centrally, and let's make that, let's see, change that to, okay, what did I just say? That's how good my memory is. My x-axis is going to go from about -pi/4 to let's just make it a little bit past, so that'd be 5pi/4, 5pi/4. Okay, so that's exactly the same as theirs, and we're going to count in steps of, not going to count in ones, we're going to count in pi/4s. There we go. So now that's the same grid size as the screen, and we go from 6 to -2 in the y direction. So we'll go -2, and we'll go to 6, and there we go. Now the screen here is exactly the same as the screen for the picture they gave us. So let's see how close we are. There's that one, and I know I've done this right if this is the same graph, and it is. It's blue, it's red. It's blue, it's red. So both of those are the same graph, and let's see. Let's move Desmos around a little bit and bring back the other window here. There you go. Maybe move that one up front. There we go. And move Desmos up a little more. And as you can see, I think we're bang on. I think we've got the exact right graph. Oh, wait a minute. Do we? Oh, yeah. We've got the peak right here and the valley right here. And this valley is, what did we say it was? It was at 1/8 of pi. Let's see if Desmos will tell us that. Is that going to be 1/8 of pi? Yes, it is. Look at that. 1/8 of pi, -1. Okay, now I just wanted to show you this, just to make sure you kind of understand. I chose for this to be my starting point, which meant that I had to put a negative when I did it in sine. I didn't have to do that. I could have actually said y equals +2, and then sine of, and then 4, open a bracket. But now, let's see, let me just get that out of the way for now until I finish it. Now, however, if I've decided that this is the starting point, so that I don't have a negative on my sine, I have to say -pi/4, because I'm starting at pi/4, and then everything else will still be the same, +1. And as you can see, this is still the same graph as the other three. It's purple, it's blue, it's red. So that whole negative could be avoided, but then I can't have a C of 0. So really, as you can probably tell from the way I'm talking, these are an absolute joy to mark, because people can have different answers, and I have to really check them all carefully to see if you're right or not. All right, I hope all of that made sense, and if you actually watched this whole video right to the end, oh, you deserve a cookie or a hug or something. Hopefully you just kind of scanned through it and found the questions and the parts that helped you. But otherwise, message me if there's anything here you need explained further. Bye-bye.